Hi everyone, nice to meet you. My name is Michael Dubinsky. I lead the PM team for ATA, or Azure Advanced Threat Protection, which we're about to introduce today. With me here is Amit, who will co-present.
Hi everyone, so my name is Amit. Michael got it right. I'm part of the ATA team, which is in charge of advanced threat analytics, which is also the team that is building this awesome new service that we are about to introduce to you today, called Azure Advanced Threat Protection, or shorter, it's Azure ATP. These are the goals we have for today, for the next 60 minutes, is to meet Azure ATP and to see it live in action. We would also leave time, about 15 minutes at the end, for all of your questions. Hopefully, we will answer all of them. And most importantly, enjoy. In your organization today, you probably have resources on premises, such as Active Directory, HR systems, critical databases, in-house applications, and more. However, over the past few years, there is a transition, which you most probably heard about and you're familiar with, which is, of course, the transition to the cloud. That transition is pretty significant, so we will talk about it now for a few moments. Most organizations are in a state of transition to the cloud, while still keeping several critical assets on premises. That is why we call this relatively old new architecture the hybrid architecture. Important to note that 9 out of 10 IT decision makers say that hybrid is their long-term approach. This hybrid architecture is a bit challenging to protect, as you have identities, applications, and data spread across environments. Some of your business critical data might reside in a cloud application or a cloud service behind APIs and not in your server on premises. To build a security solution that can protect this hybrid IT architecture, any security vendor needs to do at least 2 things and do them well. The first is to understand how advanced attackers work in this hybrid environment. For example, how do they work in on-premises environments, which tools, techniques, procedures they are using on premises, and is it any different, perhaps, maybe, in the cloud? Do they work in the same tools or other tools? More importantly, once they can compromise potentially your cloud assets, how would they move laterally inside your on-prem organization, your on-prem resources, and vice versa? How would they move between the on-prem to the cloud? So that's the first thing, to understand how advanced attackers work in this IT architecture. And the second thing any security vendor needs to do is to build a model or a strategy on how to tackle those advanced attacks. So let's talk about those 2 things. First question to you. With a raise of your hand, please. How many of you have just heard about Windows Defender ATP and or Office 365 ATP? Wow, you're good students. Very good. Now, please, second question, keep your hand up if you're currently using / evaluating either of those 2 products. Okay, you can improve there. So I definitely encourage you to, like in the first question, you heard about it. Now, I encourage you to try those 2 products out. I'll begin with a little bit of history. Since the first invention of the mechanical lock back in ancient Egypt, no security solution, and no solution, regardless if it's physical security or virtual security, no solution was 100% secure. We never reached, as a humanity, we never reached a state of perfect security. So that is why, most often, any security vendor would try to accumulate different complementary approaches, complementary products, to try and achieve that state of security. And that approach is the approach that Microsoft takes as well. Let's talk about the approach. We begin with a typical story, which I'm sure most of you are familiar with. In most attack campaigns, many, like 90% of attack campaigns, hackers get their initial foothold by phishing the user, phishing the employee. So say one of your employees received an email and clicked the attachment, which happened to be malicious. Microsoft's first line of defense against this type of attack is Office 365 ATP, which almost all of you have heard about. However, if Office 365 ATP is not in use in your organization. Or if the email came through a different path, let's say one of the employees opened up his private email account, but on a company's laptop. Then Office 365 ATP cannot help in that situation, unfortunately. Here comes focusing on the endpoint. And here comes Windows Defender ATP. It looks for suspicious activities on the endpoint itself. It monitors activities such as communication with a potential CNC server or command and control. It looks for suspicious installations in order to highlight those threats and try to isolate them as well. As you can guess, according to the same logic that I've just used regarding Office 365 ATP, I would use the same logic regarding Windows Defender ATP. In some cases, it is not in use in your organization, or the specific endpoint is not covered by the Windows Defender ATP agent. In those cases exactly, the attacker would try to steal credentials, to take those credentials and to counterfeit identities in order to use those credentials and continue the campaign. So we've gotten from email to endpoint to identities. That's what we're focusing on right now. Once an identity is compromised, usually the first step of the attacker is to perform what we call reconnaissance. Reconnaissance, as the name implies, is to understand the environment. That environment consists of, we've mentioned before, applications, data, user identities, all of which are of potential interest for me as an attacker, all of which can hide valuable information that I can later achieve with it monetization, to get money from it. After gathering that relevant information, the attacker can perform lateral movement inside the organization, whether it's on-prem only, cloud only, from the on-prem to the cloud and vice versa, as I've explained before, until he or she reaches the relevant information, perhaps using privilege escalation. Perhaps the relevant information is accessible only with the relevant identity, because the regular domain user perhaps doesn't have access to the interesting business-critical financial data. So that is why he or she may need privilege escalation. So that is we're at the final step of the kill chain. The last step is domain dominance / persistence. In order to achieve persistence, it means that he or she may leave a backdoor. It could be a malware. It could be using a technique that Michael will explain in a few moments by modifying groups. And that persistency would allow him or her to come back at a later stage. Some of you might have noticed that another branch just appeared, popped up. That is the brute force an account, which appeared just now. In our example, this kind of attack, if you look at the model that I'm describing, it bypasses all the previous steps that I've described. And the reason is me as an attacker, I can compromise an account which is accessible outside the organizational network. If, for example, it's an Azure Active Directory account, I can try to brute force it. Once I have access, I can do lots of things in your cloud environment. Lately, we're seeing in the wild a kind of a technique which is called low and slow, or password spray. How many of you have heard about it? Not many, okay, so it's good that I'll explain it briefly. It's a very popular and increasing in popularity. It uses a dictionary of passwords, but instead of trying a very high number of password guesses against each and every account, it will use a relatively low number of password guesses from the dictionary, from dictionary of popular passwords, against a very wide range of accounts. Now, why go low? Why go to a low number? You go low and slow because you don't want to get caught by mechanisms that protect against a high number of failed authentications. For example, account lockout. So if I go low and slow, in many cases, I would succeed. And we have seen like amazing / terrible stories, it depends on your point of view, of attackers that use exactly that technique for the initial foothold. So again, not phishing, not malware installation, brute force a cloud account, and from there, the story begins. So, clicker, yeah. In that last phase of the attack, where hackers can move laterally, compromise more and more credentials, escalate their privileges until they get their hands on the interesting, valuable data that they can monetize, that is the goal in 90% of the cases or more, in that phase, they will have to deal with Azure ATP. And with that, Michael.
Thank you.
Welcome.
So, as the session name suggests, we're introducing today Azure ATP, a new cloud service to detect advanced attacks in the on-premises, cloud, and hybrid environments. The goal of Azure ATP is to take the knowledge and the experience we have with ATA detecting on-premises compromised identities and extend those capabilities to the cloud. Being able to detect compromised identities on-premises, moving to the cloud, compromised on the cloud, moving to the on-prem, and everything in between. So let's have a quick look at how it actually works. So first of all, Azure ATP is a cloud service re-engineered completely from the ground up for several reasons which we'll discuss. But the first thing we need to do is to understand what kind of information we collect and how we collect it. So if you're familiar with ATA, you're probably familiar with the network traffic collection we have on premises. With ATA, we call that the gateway. With Azure ATP, we call that the sensor, and there is much more to just renaming the component, and we'll discuss that in a couple of minutes as well. But the first thing we're doing is collecting network traffic from the on-premises going in and out of the domain controllers, either via port mirroring using the standalone sensor, or via the sensor deployed directly on the domain controller. Now, the traffic we're collecting, we're not only collecting the raw information, or like other security solutions, IPS or IDS solutions that parse up to layer 4, we actually do that up to layer 7, up to the application layer of the protocol itself. So when we see a Kerberos authentication request, we actually know who is the user account that is authenticating, what are the encryption types, all the information that you're familiar with if you've looked at the Kerberos protocol using Wireshark or Netmon or similar solutions. So that's the first thing. In addition, we're collecting additional information from the on-premises, things like VPN logs using radius accounting, event logs from member servers and domain controllers, and we're constantly extending the data sources we're collecting based on the detection use cases we want to provide. The other thing is the cloud data sources, first party and third party. Currently, this is an engineering work in progress, working very hard on integrating with those solutions and collecting data with those solutions. And obviously, when the data becomes available in Azure ATP, then we'll add that to the profile and to the detection logic. But the goal of Azure ATP is to combine the information collected from the on-premises and from the cloud applications and identities in order to perform the next step, which is analyze that information and learn the user behavior. So Azure ATP is based, again, on a similar concept of profiling the entity's behavior, profiling exactly what the user does. When the user accesses a resource on-prem, when the user accesses a resource in the cloud, when the user performs authentication, all that information is being profiled and being stored in the user's context inside the Azure ATP database. That information allows us to understand exactly how the users behave and use that information in the future for detections. The other thing is IP resolution. So one of the big challenges in the security industry in general is how do we correlate an IP address to the device? Almost always, all the information we see, either in the network traffic or in the logs, are IP addresses. So there is a huge difference between saying or knowing that Amit logged in from Amit's laptop versus saying Amit logged in from an IP address 192.168.50.5. So we have a patented IP resolution technology where we take each IP address and we profile that as well to understand what are the devices that operate on that IP address at every single point in time. That helps us to build the right profile. When we see an operation performed by a user from an IP address, we can actually correlate that to the actual device on which that operation was performed and add that to the relevant profiles both of the user and of the device in order to use that in the future for detections. And the last thing, as I mentioned, it's a cloud service completely re-engineered for scale and integrations. So now that we want to add additional detection models, additional behavior models, we're no longer limited by the compute power we have on premises. We have the compute power of Azure behind that service, so it's very easy for us to constantly extend with new detections without worrying about the scalability of the service, because that's a problem solved by Azure. So now that we've analyzed and learned how the entities operate and behave, we begin detecting. So we detect abnormal behavior. Abnormal behavior are basically statistical models or machine learning models where we learn how the entities, how the users normally operate within the organization. What are the normal resources they're accessing? What are the normal devices they're using? And then we detect abnormal behavior. Basically, we compare the user's behavior to themselves, to their peers, to the organization, in order to understand what's normal and detect the abnormal. For example, if a user is usually logging in from 3 devices, and that's kind of the norm we see because most of the users have their laptop, have their mobile device, and usually an additional device like a desktop or a VDI device, then when that user account authenticates from dozens of devices, which usually is the case when performing lateral movement, we'll detect that as abnormal behavior. So that's one example. The second example are suspicious activities, activities that shouldn't really happen in a normal organization. An example for that, replication requests, domain controller replication requests or Active Directory replication requests coming from non-domain controller devices shouldn't really be happening. And that's actually a technique being used by attackers in order to steal information from the Active Directory, things like credentials, because you can do that, things like user accounts, because you can also do that using those APIs. And they perform that actually in the wild. So those are the type of suspicious activities that we can detect. Now, how do we build those suspicious activities? For that, we have the security research team that constantly looks at information available in the security market. There's a lot of information sharing happening in the security research community. So that's one data source. The other data source comes from the fact that we're Microsoft and we have thousands of enterprise customers with billions of data points of authentication and devices and logs, and we can use that anonymized information in order to understand how organizations normally work, what are the normal operations, and based on that create the suspicious activity detection that we're shipping in Azure ATP. So all the detections that we're building are actually based on real breach information, based on, again, both the information we're getting as Microsoft from our customers, including the incident response teams, by the way, that are going to customers to help them investigate and remediate advanced attacks, as well as from the security research community. And last but not least, the alert and investigation. So once we've detected an abnormal behavior or a suspicious activity, we notify the user, the security operator, by several means. We have email notification, syslog notification that can integrate with existing solutions. And we also show those alerts on a very intuitive attack timeline that provides you all the information about what happened in the organization. And usually in a campaign, there are multiple attack vectors, multiple techniques the attackers are using. So seeing those on an attack timeline actually gives you a very clear picture of what happened in the organization. In addition, each alert has a dedicated alert page, which we'll see in a minute in the demo. The goal of that alert page is to help with triaging of the alerts, very quickly to decide whether the alert that Azure ATP just detected is a true positive alert, does it make sense and worth investigating and spending more time on it, or could be a false positive alert that you can close immediately and even exclude the relevant entities for that alert. Once you've decided you want to investigate that specific alert, the next thing you can do is go into the dedicated profile page, which is actually going through a huge renovation and will be available very soon in the Azure ATP UI. And you can look exactly at how the entity operated in the organizational context. Which resources did they access, which devices they logged in, and directly from there, you can pivot to Windows Defender ATP in order to understand how the endpoint behaved. Were there any malicious processes on the endpoint? Were there any abnormal memory accesses on the endpoint? All the information available in Windows Defender ATP is actually a click away from that specific entity in Azure ATP. So you can very quickly go through the kill chain from the compromised identity to the compromised endpoint, and eventually going to the compromising email or phishing email or attachment that actually got the malware into the organization. So this is a very quick overview of what Azure ATP is. Now let's actually see how it looks like. Amit?
Okay, Okay, I'll show you. Just a sec. Okay, so now what we'll do is a fairly quick demo of the steps needed to get onboarded with Azure ATP. How would you start using it? So we would begin by creating what's called a workspace, and I explain in a moment what that is and why you need it. So famously, Contoso. A workspace is in fact an Azure ATP deployment. You can have multiple workspaces for different purposes. For example, if you have a lab environment or a test environment, you can define something called Contoso. If you work in Contoso, you can use Contoso/lab or
Anybody works in Contoso?
No.
Okay.
I used to before I came to Microsoft. So you can use Contoso-test, or if you have multiple different production environments, let's say in one continent and the other, one in Europe, one in the US, you can assign, if you want, an Azure ATP workspace for each production environment. By the way, it was done. It was fairly quick. This console that you see here, it's called, as you see the name is Workspace Management. If you want to access it, you need to be a global admin on your Azure AD tenant. So only that role has the privileges to manage the workspaces of Azure ATP. It could be creation, deletion, and any changes. Regarding data center locations, you can see the 4 workspaces that are currently configured on this Contoso tenant. They're all in the region US East. However, we will add, and we are currently adding more regions to be supported. And during the preview phase, we will have the Europe West region as well. I know that most of you are asking that, or some of you. Regarding user roles, if you can see the top right corner here, where my mouse is, manage Azure ATP user roles. So if I would click that, I would get to the relevant blade in the Azure portal. And you can see that for each workspace that is defined, we have those 3 different groups. Each of them defines a role. From the least privileged to the most, those are viewers, users, and administrators. Pretty straightforward. Users are the ones that are supposed to use Azure ATP on a day-to-day basis. They can not only view the console, but also make certain changes to it. For example, work with the alerts, which Michael will show in a few moments, how you can work with the alerts and investigate. Viewers are less privileged. They can only view the console. And administrators are like users with benefits. They can make certain changes to the configuration screen, which we would also show in a few moments. So those are the 3 groups. Now back to our workspace management. Let's click on the workspace that I've just created and see what we need to do in order to get fully onboarded. Okay, welcome. Does this look any familiar? How many of you have seen a similar screen before? All right, so those that have their hands up, I know that you have been either using or trying ATA. And the guys from Microsoft, that doesn't count. That's not relevant. You're part of the team. Doesn't make sense. So anyone that raised his or her hand, I know that you've been trying ATA. Good for you. Those that haven't, shame on you. You should try. This looks very familiar to ATA because we are leveraging. We have very good feedback on the timeline and the way that the user interface works. That's why we migrated the same user interface to Azure ATP based on customer feedback. The first step that we need to do, the mini wizard says, is to provide a user in Active Directory, the on-prem Active Directory, and that user is used by the service in order to query information from Active Directory, such as, for example, which users exist in Active Directory in your domain and which groups exist. This is a baseline of information that the product needs. I would like to note that this user is non-privileged, is contrary to many security solutions out there. We don't need any domain admin, God forbid, which makes it more secure if, God forbid, the product is compromised. So this is a regular, non-privileged domain user, and we're done. The second step, according to this wizard, is to download our first sensor. And as Michael said, it's no more a gateway, it's a sensor. We'll talk about the other changes beside the renaming. I'm starting the download process, which would take a few moments. And that is why I've already downloaded it before, and copied it to my DC. Let's save it in the background. I'm now using RDP to my DC. It says right there, domain controller. And I have the package. I just copied it and extracted it. The zip file contains two simple things, the installation executable and a JSON file with a few simple configurations. For example, what is the workspace ID and the URL of the service. So let's run our first sensor deployment. Choosing English. I only know English and Hebrew, so we would go with English. It has two options, but only one is really available. The first is sensor, the second is standalone. If you can see I hope you can see the font. Sensor, because this wizard automatically recognized that, hey, I'm being run on a DC. So you can only have an agent on the DC. There is no sense in running a standalone sensor because that's a different deployment option. Standalone, just to be clear, it means that you have a non-DC Windows Server machine, which is used together with port mirroring in front of which DCs you want to cover, and you install your sensor there on a standalone server. So I'm going with the direct agent. You can also see that I'm being asked to provide an access key. I will show you when we come back to the console. I've got this access key from the console itself. Very simply, it is used to establish trust between the sensor on-prem on your DC and the cloud service. That's the mechanism that we are using. While the installation continues, it would take approximately 45-50 seconds. I will tell you that your sensor needs to communicate with our cloud service. So for that, you need to open up a rule in your firewall, or you can configure it in your proxy for the communication to happen. And that communication, it's simple to explain, but it's very rich and very sophisticated in its content, is all the parsed information up to layer 7 that the sensor is analyzing and heavy lifting all the traffic up to layer 7. So it's a bunch of protocols, Kerberos, NTLM, LDAP, NetBIOS, DNS, many buzzwords. All of that, only the extracted information in a compressed way, saving lots of bandwidth, is being actually sent to the cloud. So you just need to configure your either proxy or firewall for that communication to take place. So I think it was less than 50 seconds. Done with the sensor installation. That's it. Let's go back to the console. I hope it registered. Yes. So what we have now in the workspace, we have Amit DC. This sensor successfully was installed directly on the DC and registered in front of the service. What we'll do now, you see this little toggle button here at the bottom? Remember that Active Directory user I mentioned, that it's a non-privileged domain user that is used to query Active Directory? Yes? No? Yeah? Most of you are saying yes or sleeping. So that user, that's exactly where it's being used. I need to assign the role of which is the sensor that is actually doing the querying in front of Active Directory. Not every sensor needs to do that, just one per your domain. So in my case, I only have one sensor. I'll use that one. Let's save it. Done. That's all we need to do when it comes to getting the minimum necessities of installing and getting on board with Azure ATP. And we've just installed our first and one only sensor. However, there are a few extra steps that are very much recommended. Let's go to notifications. There are two kinds of notifications that you would want to configure. The first is whenever a new security alert is generated by the product. The second is whenever there is a health issue that arises about the deployment itself. So say, for example, somebody changed the proxy configurations, or the sensor itself is not running properly, you would want to notify the relevant team. So for a health issue, I would notify the DC ops on Contoso. And for the security alert, I would alert via email to analyst, of course. That's it. Done. Very simple, very easy. There are other kinds of ways to extract information from the Azure ATP deployment, not just via email. You can also configure, for example, via syslog. So any other product, for example, a SIEM that can ingest syslog, can also ingest our notifications. So you can have all the alerts generated by Azure ATP show up in your SOC operation / SIEM, whatever you are using as another console. Let's go for a second to scheduled reports. You can see here there are today 3 types of reports that Azure ATP can generate. And we are working, this is a work in progress, that every couple of new releases in the cloud service, we want to add more reports. Some of them relate to hygiene stuff, like any passwords that were exposed in clear text. That's a clear hygiene issue. You do not want attackers to easily pick up passwords that are being sent in the clear. And there are other types of reports. In this example, what I'll do is schedule a summary report. A summary report could be sent, for example, for the SOC manager not every day, let's not exaggerate. He has other stuff to do. Let's do it every Tuesday. SOC manager, guy, girl. Let's be fair here. Okay, done. Saved, he will get a summary report. Michael will show you in his demo an example of one of those reports. Would it be the groups?
Yep.
The groups.
Sensitive group modification.
Yeah, he would show you the second example. What other stuff we can do as part of the deployment process? 2 things that are kind of neat: honey tokens and sensitive tagging. Honey token accounts are, how many of you are familiar with the concept of honey tokens? Okay, less than half. I'm surprised. All of you are supposed to be familiar, and I will now tell you. Honey token accounts it's a very, very simple concept. These are accounts that should not be used by anyone in your organization. And they're called honey because they're used to lure attackers to try and use them. So for example, I would use a sexy name like a SQL admin, which I don't really need in my organization. Perhaps I'm not using a SQL. But it has an alluring name to attract attackers. And any such activity with that account, even a simple one such as login, would get alerted as if it was a very suspicious thing, because it is. Nobody should use that. So let's use the SQL admin. Done. Another thing I can do, Azure ATP has a built-in definition of which are the groups and accounts that are considered sensitive. It means that those accounts are more easily tracked by the SOC manager analyst. You can more closely track them. And it also has an impact on some of our detections. Some of the mechanisms take into account that if you see an activity with an account that is sensitive, then something changes in the detection mechanism. So, for example, if I would search for admins here, you would see that specific groups, like schema admins, enterprise admins, domain admins, of course, have that green sign, S. I can also add some of my own. Let's say I want to add the CEO, and let's see that the CEO doesn't have any. Azure ATP cannot, or we haven't developed that yet, that does not recognize the CEO as someone who is necessarily sensitive, but you know that he is sensitive because he or she has access to sensitive information. So currently no sensitive icon, but I want to add him, and perhaps I want to add his COO as well. And maybe while we're at it, let's add the finance, because they also have some sensitive data at their disposal. So saved. Let's see. Finance are now sensitive, and CO, he is. So at least on the icon level, it works. Hopefully, it also works on the detection mechanism. So yeah, you see a green icon, yay. But trust me, it should work also on the detection level. So we've done the tagging and the honey tokens, notifications, schedule the report. We can do there behind every tab here. There is some configuration that is recommended. I won't go through all the possibilities. Just one more thing. Strictly related to the Azure ATP, the service. Regarding the integration with Windows Defender ATP, Azure ATP automatically recognizes if there is a valid license for Windows Defender ATP on the same tenant. So you have the Azure AD tenant, you have multiple instances, multiple workspaces of Azure ATP, and you might have, if you are entitled to, if you've purchased it, you have the Windows Defender ATP license as well. So we can automatically check all the licenses are defined at the tenant level if there is a license. If so, this toggle button would appear. The only thing you need to do is on and save. So I'm looking at Michael because if I would do that, I would take the integration to my workspace.
He would break my demo.
I would break his demo. The reason is because he has a different workspace, and it's a one-to-one mapping. Currently, you have one workspace that can work in front of the Windows Defender tenant, Michael already did the integration, so I won't hijack the integration back to my workspace, but it's a one-to-one mapping. So you can choose which of the workspaces should be the one that is working with the Windows Defender tenant. As you can see, this is the message that I'm getting, that ignite-doobie-ad is already using the integration. Okay, back to the presentation. Let's recap what we just did. The first 3 steps, as mentioned, are the necessary ones. The other 5 steps are optional, but very much recommended. You've seen how easy, fast. I've gone through most of the deployment steps there are in the product, and it took me 10 minutes, I think, maybe 15. And the last 2 things I want to mention is that you can also ingest relevant security events from your SIEM and from your VPN solution. Different protocols. The SIEM, it would ingest syslog, and from the VPN, it would use radius accounting. But those are also very much recommended. It's just that we haven't gone through those steps right now. We'll do questions at the end of the last 15 minutes. Okay. With that, I would just want to talk a few more moments about the sensor that we've mentioned a few times. And then we'll move to another demo about the attacks and alerts themselves. We have worked very, very, very hard on choosing a new name for the gateway. Very hard. We've chosen the sensor. And that's it. No, we've also done a couple of more things. And the couple of more things are, besides the name, which was a lot of work, more work was invested in completely redesigning and re-engineering the parsing platform, which is the component that does all the heavy lifting of parsing the raw network traffic, all the bunch of different protocols. So there is an example on screen, but there is somewhere around an order of magnitude more, there is more efficiency. It's more efficient, the new sensor, compared to the older gateway or lightweight gateway, both in terms of memory and in CPU when it comes to the impact on your DC. This has a lot of meaning. Yeah. I didn't do it, but yeah, these guys probably did. Yeah. He's not here. Like, Bao. Send a message to Bao. Send him something. So it has a lot of meaning, a lot of impact for many customers, because it means that they don't need to add, in many cases, don't need to add or change anything in their DCs. They're good to go. From the get-go, just install the sensor, you're done. Don't need to add memory, no need to add CPU. Of course, it all depends on the amount of network traffic that DC is actually getting hit with, but in many cases, it's a huge improvement compared to the older sensor, the older gateway. So I think with that, I've done with my part, and let's go to the second demo.
Great. So thank you, Amit. So now let's actually see how Azure ATP detects suspicious activities and alerts. So here we have a different workspace in the same Azure AD tenant. It's already pre-populated with several suspicious activities or Azure ATP alerts. The first one is the reconnaissance using account enumeration. So as Amit mentioned, during the attack phase, in many cases, the attackers begin from having zero knowledge about the environment. What kind of resources do they have? What kind of servers? What kind of accounts? What are the user accounts? Things like that. So in this example, the attacker started using a reconnaissance in order to guess the usernames that exist in the organization. They attempted to perform some privilege escalation using a known vulnerability, which was also detected by Azure ATP. And eventually, they performed reconnaissance using DNS, which is attempting to identify all the resources, all the servers that exist in the environment. This is where we are at this point in time. Now, the next thing the attackers would do, let's take this example. That's a VM controlled by the attacker. They have the usernames. The next part of the attack is to try and brute force those accounts, as Amit mentioned, using a low and slow or a password spraying technique, because they want to avoid detection. So in this example, we have 100 user accounts in this environment, and we're going to attempt a total of 200 passwords on those user accounts. This is how we're going to run the brute force from that specific device. And currently, the tool uses Kerberos authentication protocol in order to perform the brute force, but obviously it could be with any other protocol that we're executing. And we can already see that Azure ATP has detected the suspicious authentication failures on the timeline. Now, going into that specific alert page, we've also redesigned some of the alert pages, and we'll complete the redesign in the next couple of months, that we're showing exactly the reason of why that specific suspicious activity was detected. In this example, we can see that Azure ATP learned that there is excessive number of authentications from a single device for multiple accounts. Now, refreshing that actually shows that it's constantly being updated with the number of authentications and the amount of time. So the cool thing about it is not only the detection, but how fast the detection works. From the moment I hit enter on the brute force until the moment the alert actually popped up in the Azure ATP console, it was a matter of seconds. It's the only solution available today that actually detects alerts as quickly as it does. From the moment the attack begins until the moment the detection fires, really it's a matter of seconds or minutes. That's it, given even the cloud on-prem communications. Now, the other thing we can see here, we can see the evidence about exactly what happened. So looking at the evidence, we can see that that specific endpoint was active for a while without any failed authentications. We can also see that none of the passwords that were attempted for this operation are one of the previous passwords that the users were using. So one of the known false positive, or one of the general issues with brute force detection, is the fact that a lot of the time you're hitting false positive because the user changed password, they still have an old session logged on, you have a service account where you change the password, still running some applications. So those are very common false positives technique that we avoided. And we can see that eventually the Help Desk North America account has successfully logged in after multiple authentication failures, leading us to think that the brute force was successful on that specific account. Now, going back to that specific endpoint, we can see that we found valid credentials for the Help Desk North America account, and we can see its password. So the next thing I'm going to do as an attacker, I can check, I know from the reconnaissance phase that it's a privileged account, and I can use a persistence technique that basically means I will add an attacker-controlled account. In this example, the attacker controls an account called Jeff V. I will add that account to a sensitive group, but I will not add it directly to the domain admins group or enterprise admins. I will add it to a subgroup of a subgroup of a subgroup, which would make it much, much harder on the detection itself to understand that. So I'm just going to open a command prompt using the compromised account. So I have the username and the password in front of me. The chances of me doing a mistake are really low. And now I'm going to add that specific user to a sensitive group. So I'm going to add that user to the Help Desk Europe group. I can see the command completed successfully. And switching back to the Azure ATP console, I can already see that we've detected an abnormal modification of sensitive group, saying that that specific account has I can't pronounce that word, has modified, let's skip it, has modified a sensitive group. So we can see, again, in the evidence, when was the last modification. We can see exactly why did Azure ATP decide that specific group was sensitive, and that's where the sensitive group tagging actually comes into play. So those groups would be considered sensitive as well. And in the evidence themselves, in order to help with the investigation, we can see exactly which endpoints that specific user was observed logging into. So I can see that in the last couple of days before the modification, the Help Desk account logged into that specific endpoint. Obviously, it could be a bunch of endpoints. Now, going into the endpoint profile, I can see all the security alerts in Azure ATP that endpoint was involved in, which already leads us to think that there is something going on from that specific endpoint. And already from that specific profile, I can see that I have 2 Windows Defender ATP alerts firing on that specific endpoint. So already during the investigation phase, it's very easy for me to correlate that information, understand, and say basically, hey, there is something going on with that endpoint that Azure ATP detected, but there is also something going on that endpoint that Windows Defender ATP detected. Clicking on those alerts would lead us to the exact profile in Windows Defender ATP, and we would see the exact alerts we have on that specific endpoint. We would see, obviously, the context in Azure ATP, and we could begin the investigation to understand exactly what were the malicious processes, how they communicated, and eventually perform the investigation, pivot the investigation, again, from the compromised identity, which was the help desk account, understand the scope of exactly what happened, pivot to the endpoint, and then begin understanding how the attackers managed to gain their presence on that specific endpoint. Whether that's using a malware, maybe it's in memory, was there a phishing email that landed on that specific endpoint? That kind of information is available in Windows Defender ATP. Now, one last thing before we finish with the demo. Once we've detected the abnormal modification of sensitive group, I can also go to the modification of sensitive groups report and download that report to see were there any other suspicious modification. I can basically go and hunt for that specific attack vector once I've detected that the attacker is using that in my organization. So I've pre-downloaded the report I have in my environment, so obviously there is not a lot of changes. But the interesting thing is that I have all the raw information that caused us to see those specific modifications. So I can go into the event section. That specific detection and report is based on the modification event collected from the domain controller by the sensor. By the way, the sensor automatically collects all the relevant information, all the relevant events that are required for the detections and the reports. And I can use that information in order to understand which changes actually happened on which domain controller and by which account. So this is for the detection demo. So what have we seen? We've seen real-time detection detected in a matter of seconds from the on-premises environment. We've seen a password spray detection successfully brute forcing a sensitive account. We've seen a persistence technique a lot of cases used by attackers, which is modifying sensitive group and gaining persistence using that method. And we've seen how we can go down or up, depends which way you look, the kill chain to understand from the compromised identity to the compromised endpoint and eventually to the compromising email attachment or URL. So Azure ATP, Azure Advanced Threat Protection, is the new cloud service we're announcing to detect advanced attacks in the on-premises, which you've seen today, in the cloud coming in the near future, and the hybrid environment basically tying those two detections together. We're leveraging the know-how we have from ATA, from Advanced Threat Analytics, the on-premises solution, in order to do the same kind of work we did on-prem and bring that to the cloud. And with that, we're also announcing the limited preview of Azure ATP. You can go and register to the Azure ATP limited preview today. As you've seen, it's super easy to deploy. You just deploy the sensor. There is no impact or minimal impact on the domain controller. There are no hardware requirements for the on-premises to deploy anything in order to deploy Azure ATP. And the Windows Defender ATP integration is already built into the product. So go to AKMS Azure ATP, register there today. We'll contact you in the next few weeks with the onboarding steps and any information required to onboard the service. And we're looking forward to your feedback. Some additional sessions about ATA and Azure ATP we have today and tomorrow. And with that, we're open to any questions you have. Thank you very much. If you could just go up to the mic so we won't have to repeat the questions. Thank you.
So if you're on-prem only,
yep.
what are your options?
If you're on-prem only, you can continue using Advanced Threat Analytics. We're going to continue ship updates to Advanced Threat Analytics, just not the cloud relevant sections and the integrations with the other cloud services. But ATA is still going.
How does this play with tools like SEAM tools like Splunk and Logarithm? Is this supposed to be a competing technology? Are we supposed to link them together? What would we do there?
The products that you've mentioned, like Splunk, are in the SIEM category. Azure ATP and both ATA, Advanced Threat Analytics, are not a SIEM. SIEM have features like log aggregation and can contain a history of many, many logs that we do not have. We do, however, offer complementary features that any SIEM solution does not have. For example, our detections are not available in any SIEM solution, not that I know of. And the advanced investigation experience, not just the detections itself, are also very unique to both ATA and Azure ATP. And one of the key differences, just one of them, beyond what I just mentioned, is the data source. SIEM do not rely on raw network traffic. They aggregate logs. Many attack campaigns can be discovered using event logs. That's good, and we're also looking at logs. But many attack techniques are undiscoverable when you just look at logs. Moreover than that, logs can be tampered with, can be deleted. That's one of the things we see in the wild, that attackers immediately delete logs. So it would be practically invisible to the SIEM. So long answer, and the short answer is it's different.
So is the ATP offered through EMS and this Azure ATP is the same, or is it something different that we are talking here? Sorry, ATA.
So in terms of pricing and skewing of Azure ATP, we'll announce that at a later stage. We're announcing the limited preview today. ATA, the on-premises solution, is part of EMS E3.
Azure ATA is a different solution than regular EMS ATA solution. That's just on-premises, right?
ATA is an on-premises solution, yep.
And the sensor that we are going to install, if we have got multiple domain controllers, do we need to install on all the domain controllers or just one is enough?
Depends how bad you want to catch the attacker. If they're going against the non-covered domain controllers, then
that's
ATA or Azure ATP won't be able to detect.
And the one workspace would work with multiple domain controllers, right?
Yeah, so currently each workspace in terms of limitation is limited to a single forest. If you have multiple forests, then you'll need multiple workspaces, but that's work in progress to support multiple forests in the same workspace.
Thank you.
Hi, for the future cloud integration, are you planning to integrate with Azure AD identity protection and maybe cloud app security?
Yes, I'm actually currently personally working on that feature. So it is a work in process, not yet available in the limited preview, but will be soon.
Okay, so that will be some kind of aggregated view across the different tools?
Yes, Azure AD Identity Protection Center is focused on the compliance, but not compliance, but the to have limitations. For example, if you want to have policy for 2FA, conditional 2FA, they would keep developing that part. What we would provide are security alerts, additional security alerts, on top of what Azure AD are providing today, focusing on which techniques are in the wild, catching those and presenting those in a easily explainable way, like Michael has presented, all the reasoning, all the evidence. Yeah.
Okay, thank you.
So are these two different products? I mean, if we're an on-prem ATA customer now, will we migrate to this? Will we buy this? Do we continue deploying it? Wait till this is out?
So in terms of what you can do today, ATA is a GA product. You can deploy it in production, use it. So that's where it is. Azure ATP, we're announcing limited preview today. So it's a preview release. You can evaluate it today. You can obviously deploy a full-blown production deployment of Azure ATP, but still, it's a preview product, right? So it would take some time to GA that. In terms of the migration, depends if you're fully on-prem, then yeah, keep using ATA. If you're using cloud identities, cloud assets, then you should look into Azure ATP.
Are you going to integrate with OMS in the near future?
We have that in our roadmap. We cannot commit yet as to specific dates, but we are considering all the different first-party, all the different Microsoft solutions today, so it is in our roadmap.
Would you go back a screen so I can take a picture, please?
Yeah. Okay. Yes. Next question.
Yeah, you noticed that there was an email notification as well as syslog notification to go into Seams.
Yeah.
I'm just curious, before we GA, is there an intent to get on Azure Events where additional protective or responsive technologies might be able to take action based upon some of these high probability alerts?
So it's not something that we've committed to GAing with, but it's definitely in our roadmap.
The sensor now instead of the gateway, are those improvements going to come to on-prem ATA?
Yeah, we're
And
sorry.
second question is, if you are on-prem ATA and you want to evaluate this, would it be bad to run both?
Okay, so for the first question, yes, we plan to migrate all the improvements we've done, me personally, no, not me, the team, to the sensor, back to the on-prem product, so yes. And for the second question, you do not want to run both the sensor and the lightweight gateway on the same DC. You want to have a separate DC for the sensors, separate environment for the Azure ATP sensors, while keeping the lightweight gateways if you have for ATA.
How do we deal with multi-geography locations? So as you can imagine, very frequently the same user credentials could be used in multiple geographies at the same time. So how do you cross-correlate this type of attack?
So if it's, we're profiling and we're learning the normal behavior. So if the same user is working, let's say a service account, right, is operating in multiple data centers and we learn that as normal, then yeah, that's okay. There is no issue. Yeah, so if, okay, now I got the question. So in terms of the Azure ATP sensors, all the Azure ATP sensors for the same workspace communicate with the same endpoint, right? So if you have an East US workspace, then even if you deploy a sensor in Europe, it would communicate with the East US endpoint, right? So you have two choices right now. You can either create two workspaces, but then you're right, the information will not be correlated, or you could create a single workspace and send all the information there. Sure.
How would this work with the multi-tenant AD?
What is that, sorry?
Multi-tenant.
Multi-tenant? Multi-tenant AD? Okay, so we work, as I've mentioned before, if you're saying if your company has multiple tenants?
Different customers in
like
same AD with their own tenants.
Like an MSSP, if you have a single Active Directory domain that serves multiple customers, so the deployment scope is the Active Directory forest. So you would have a single Azure ATP workspace. I mean, you could create multiple Azure ATP workspaces based on domain controllers, right? But eventually you would have a single Azure ATP workspace. That would be the recommendation for correlation of the data that would see all the traffic, right? So currently there is no...
I see all customers in one tenant.
Yeah.
For an Active Directory domain services. We're talking about the on-premises Active Directory domain services. Obviously for Azure AD, we support multi-tenancy.
Will the performance enhancements come to the ATA, DC Agent 2?
Yeah, we had that question a few moments ago. Yes, it would be migrated in the near future back to ATA.
Regarding the evidences that you were providing when you attempted to perform brute force attack, you showed that the password that was attempted wasn't one of the previous passwords. So I guess you're keeping some kind of trace. I don't know if it's a password clear text or the hash in some kind of database. How can you do that?
So the answer is no. We're doing that without storing the passwords or the hashes of the passwords. There are some other technique based on the fact we're leveraging network traffic and some additional querying we can use in order to identify whether that's a previous password. So we're not storing any passwords or password hashes, except for the service account of ATA, of Azure ATP.
Okay, and I guess that it only works after the initial change of password when you've installed the product? Because you have no clue to know what was the previous password.
No, it works even without. So again, we're not relying on the password hashes or things like that. Magic.
Okay.
In business terms, it's called intellectual property, but yeah.
Okay, okay, thank you.
Great. Last question? Yeah.
Can you go back one more screen, please, to the URL?
Oh, yeah.
And also the question actually is you had mentioned that you're able to identify the devices simply based on the IP and that there was some secret sauce that went into that. Can you elaborate a little bit on how it identifies the device itself only based on IP? Like, is it using metadata of some sort, or is it
magic?
Yeah, no.
We have several ways. Some of them are passive, looking at, let's call that hints at the traffic, passive ways of what happened in the different protocols that are hitting the domain controller. And there are also active resolution methods that we would go and call out who is behind that IP, and cross and do the intersections between what we've seen in the passive methods together with what we've seen from the active resolution method to achieve a very high level of confidence in resolving the device behind it. Make sense? Okay, that was the last question. So thank you very much.